Alright, this is how my graph ended up looking. I graphed from 1 to 5 minutes across the bottom and an elevation from 0 to about 150 feet up the vertical axis. Now it's okay if yours looks a little bit different. In fact, the first time I graphed this, my graph turned out completely different. Just based on scale, simply. So I was able to graph up to 4 minutes. But perhaps you needed to do a little table of values like I did in order to get a couple ordered pairs that we could then graph. Now that we have taken care of graphing our equation, we still have one more question that it's asking us to do. Interpret the intercept at which the graph intersects the vertical axis. Vertical means up and down, so I'm looking at what it means where this graph hits the vertical axis. And as I'm looking here, it looks like it's this point right here. Now when I see that on my table of values, I'm looking at this value right here, because it's where my x hasn't moved side to side. My time is at 0. To interpret, it just means we're trying to define what this means in real life. When I interpret my vertical intercept, first of all, I want to identify what it is. 0, 12. And now I'm going to interpret what each of these numbers means. This 0 stands for how much time I've given it. So at 0 time, this balloon is at a height of 12 feet. So when I interpret the vertical intercept, I'm simply explaining what each of these numbers means. I've chosen to write mine like this, that at 0 time, or before the balloon launches, it is at a height of 12 feet above sea level. That's its current elevation. Here's your challenge. We'll try to hit a pause on this and work on part B. This time the balloon is descending at a rate of 20 feet per minute with a starting elevation of 1,350 feet, 1,350 feet. It asks you to write an equation, identify the slope of the line. Hint, hint, slope and rate are the same idea. And then interpret the h-intercept. H would be height. So again, this is our vertical axis. Please try this question on your own.